Hello all, welcome back. In this session, we are going to solve another DSA problem which is titled as longest consecutive sequence. So first let's try to understand the problem statement. You will be given an integer array and you have to identify the longest consecutive sequence that can be seen within this particular given list. So in this example, it's given 100, 4, 200, 1, 3, 2. So in just by looking at, we can identify, we can form a consecutive sequence of 1, 2, 3, 4. So these numbers are already there. So we can identify just by looking, there is a consecutive sequence 1, 2, 3, 4, and that itself is the longest consecutive sequence. And what we have to do, if there exists such longest consecutive sequence, we have to return the length of that consecutive sequence. Here the output would be the particular length, that would be 4. Like that we have to do, and the given list is not sorted, it is unsorted, and it is mentioned that whatever the approach you are going to select, that should be done in a time complexity of order of n. So how can we do that? So let's think about moment. So one thing we can do is that we can sort it, and we can see whether starting from one particular pointer or next pointer is having n plus 1 or not. But sorting is not a solution because it's mentioned that you have to do in order of n. The sorting itself will make it in n log n. Another n to check whether it's proper, there is a sequence, and update the length of sequence to n. So this is not the way as the problem demanded. We have to do in order of n. So here what we can do, we can utilize the hash set concept. So hash set is nothing but it will only store unique elements. If it appears more than one time, it is not going to store in that particular data structure. That's how that feature is what we are going to utilize in this particular problem. So let's try to code and see how we can like answer this particular question. So this is the class solution, and the method inside the class named as longest consecutive. And what are the arguments? The arguments is nothing but given integer list. Then what else is given? Nothing is given, but you are supposed to return an integer. That's the length of maximum consecutive array that can be formed using. So we am also going to fix a counter. This will be updated based on how much consecutive sequence we have seen so far or not. And I'm going to like define the set data structure. So set, this is a syntax for making the nums array stored only by the unique elements. So my set equal to set of nums. Now we can see whether a particular element is present in my set or not just by lookup with a complexity of O1. That's a good thing. Unlike we are searching for an element inside an array with a complexity of order of n, here the set data structure allows lookup in order of 1 time complexity. So we can always see whether it's present or not in a much more better fashion. Then what we are going to do, we are going to see whether a particular num, we are going to iterate now for num in my set. So this action is order of 1, unlike searching anything else. So if for num in num we have to see whether it is the starting point of a sequence or not. How can we see that? Just see whatever the number below it present in or not. If it's not the case, then that's the starting point. So we have that's the thing which we are going to do in the next step. If num minus 1 not in my set, that means that is the starting point, then we can update current is equal to num. Since it's a starting point, now let's update the length of the sequence. Let's give it a name called sequence equal to 1. Since we have identified the starting point, now we can keep on seeing whether plus 1 like value present or not, plus 2 value present or not, and we can keep on going as far as the sequence is going to get terminated. So we can just search, keep on searching while the current plus 1 in my set, if it's present, we can update current also, and we can update the sequence also. And once the sequence get terminated, we should check whether the existing count or the count corresponding to the current sequence is higher or not. That we can check. So here that would be count is equal to maximum comparison between the existing count and the sequence which we have found just now. And once this is done, we just need to return count. An important point, what is the time complexity here? Does it meet the expectation of the problem statement? Yes, it does, because first of all we are going to iterate through each and every nums in my set. So this, even though the lookup is order of 1, we are going to for each and every variables in the my set. So this would give us a time complexity of order of n, and lookup like if num1 not in my set or not, these are everything are order of 1. So this matches with the expectation of the problem statement. So the time complexity here is nothing but order of n. And what is the space complexity? Since we are using hash set data structure, that also will take extra space, which is causing us space complexity to be order of n. So that's it about this particular problem. I hope you understood. Thank you for listening.